All right, today we're talking about something with a name that sounds, well, straight out of a spy movie, MongoBleed. And believe me, the story behind it is just as wild. We're talking about a single, tiny line in code, thousands upon thousands of exposed databases, and just a whole lot of chaos and confusion.
I mean, just imagine this for a second. What if you could make a database just bleed out its most sensitive secrets? And I'm not talking about guessing passwords or some complicated hack. No password needed at all. Just one clever little trick, and suddenly it's spilling memory fragments. We're talking credentials, API keys, you name it. That is the terrifying reality of MongoBleed, and that's what we're going to unpack.
So when this thing first hit the scene in late 2025, it was pure chaos. The internet basically exploded with reports tying it to this huge hack at the gaming company Ubisoft. Everyone just immediately pointed the finger at MongoBleed. It looked like an open and shut case, right? Well, not so fast. As security researchers started digging, they found out the real story was, well, a lot more complicated. It was this tangled web of different hackers, different motives, and a whole bunch of smoke and mirrors.
You want to talk about a tangled web? Check this out. You had one group that, yeah, they did hack the game Rainbow Six Siege, but it had absolutely nothing to do with MongoBleed. Then you had a second group claiming they used MongoBleed to steal a bunch of source code, but that was almost certainly a distraction, a red herring to hide how they really got in. And of course, you had other groups just jumping on the bandwagon, trying to extort Ubisoft, basically just lying. So here's the bottom line. The whole Ubisoft drama? It wasn't the real MongoBleed story. It was just noise that distracted everyone from the actual, serious vulnerability.
Okay, so let's cut through all that noise. Let's separate the fact from the fiction here. What is MongoBleed really?
So at its core, MongoBleed is what's called a memory disclosure vulnerability. Fancy term, right? But what it means is an attacker from anywhere in the world can send a very specific kind of message to a MongoDB server and trick it. Trick it into sending back little bits and pieces of its live memory. Now this memory isn't just empty space. Oh no. It's filled with leftovers from whatever the server was just doing. And that stuff can be super sensitive. The absolute scariest part though, it's completely unauthenticated. Let me say that again. No username, no password, nothing needed.
And that name, MongoBleed, wasn't an accident. If it sounds familiar, it's because it's a direct nod to the infamous Heartbleed bug that rocked the internet years ago. And honestly, the comparison is spot on. Just like Heartbleed, this vulnerability lets an attacker just quietly and repeatedly bleed information out of a server's memory, bit by bit. They can just siphon off secrets without anyone even knowing they're there.
So, the big question is, how does this actually work? How can an attacker pull this off? It sounds super technical and complicated, but the way it works is actually kind of brilliant in its simplicity. It all comes down to tricking the server, basically breaking the trust between the computer sending the message and the server receiving it.
All right, so it's basically a two-step trick. Step one is the lie. The attacker sends a compressed message to the server, but they lie about its size. They say something like, hey server, I'm sending you a tiny file, but once you uncompress it, it's going to be huge, like a full megabyte. The server, being trusting, says, okay, and sets aside a big 1 megabyte chunk of memory. But the real file is tiny. So now you've got this huge empty space in the server's memory. And here's the kicker. In C++, that empty space isn't really empty. It's filled with whatever data was there just a moment ago. We call this dirty memory. Then comes step two, the leak. The attacker sends a deliberately broken command. The server, trying to be helpful, sends back an error message. But guess what it includes in that error? The chunk of data that caused the problem, which now includes all that juicy leftover memory it was never supposed to share. And would you believe that this entire massive vulnerability comes down to a mistake in a single line of code? I'm not kidding. Look at this. The old vulnerable code told the server to report back the size of the entire memory buffer it set aside, the one based on the attacker's lie. The new patched code, it simply reports the size of the actual data that was written. That's it. Such a tiny, subtle difference, but that one little mistake is what opened the floodgates for this whole mess.
Okay, so now we know how it works, but the next question is, how bad was it? Like, what was the real damage out there in the wild? Well, when you see the numbers, they're pretty staggering. So, get this. Right around the time this was all discovered, security search engines like Shodan and Census did a scan of the internet. They found over 213,000 MongoDB databases just sitting out there connected directly to the public internet. And out of those, they confirmed at least 87,000 were potentially vulnerable. Let that sink in. These aren't servers hidden away behind layers of security. We're talking about databases just sitting there, completely exposed, like an unlocked door on a busy street.
And it wasn't just old school servers in a closet somewhere. The cloud was hit hard. The security company Wiz did some research, and what they found is just, wow, a shocking 42%. Nearly half of the cloud environments they looked at had at least one vulnerable MongoDB instance inside them. It's a perfect example of how one tiny flaw in one popular piece of software can create this massive ripple effect across the entire cloud.
So what kind of stuff is actually leaking out? What are these secrets? Well, the memory that bleeds out is basically a random grab bag of whatever the server was just working on. And that can include the absolute crown jewels of any system. We're talking database usernames and passwords, active session tokens for logged-in users, API keys that unlock other services, chunks of private customer information, and maybe the most dangerous of all, cloud access keys. Finding one of those in a memory leak is like finding the master key to the entire building. And I love this quote from a post on Reddit because it just nails it. It says, "This is not RCE. This is RCE adjacent." So what does that mean? RCE, or remote code execution, is when a hacker can literally run their own code on your server. It's a game over. MongoBleed doesn't do that directly, but by stealing the keys, the credentials, the API tokens, it gives an attacker everything they need to just waltz right in through the front door of your other systems. So it's adjacent to a total takeover. If you leak a cloud key, you basically handed over control of your entire cloud environment.
Okay, so the threat is obviously huge. The potential damage is massive. The next logical question is, how do we stop it? How do we stop the bleed? Let's talk about the fix and the steps you can take to make sure you're safe. And you really have to give MongoDB credit here. Their internal security team found this bug on December 12th, and they did not waste any time. As you can see from the timeline, they jumped on it immediately. Within a week, just 1 week, they'd already patched their entire Atlas cloud service. That means tens of thousands of their customers were protected automatically, without even lifting a finger. Only after that was done did they go public with the details so everyone else could get patched.
So if you're out there running your own MongoDB server, the advice is super simple and super clear. Step 1, and this is the big one, patch. Immediately. Upgrade to a fixed version. That is the only real permanent fix. Now, if for some crazy reason you absolutely cannot patch right this second, there's a temporary workaround. You can turn off the zlib compression feature. And finally, step 3, which is honestly just basic security hygiene. Don't expose your database directly to the internet, ever. It should be tucked away safely on a private network where nobody can get to it.
And really, that brings us to the final, most important lesson here, perfectly summed up by this quote: "Patch this, then ask why it was reachable." Look, the immediate task is obvious. Patch the bug, fix the code. But the bigger, more fundamental question we all need to be asking is, why on earth was my database server connected to the public internet in the first place? MongoBleed is more than just a bug. It's a wake-up call, a really powerful reminder that we need to get the basics right and build our security from the ground up.